example, we're going to use elimination to solve this system of equations. Keep in mind, you can always use substitution. It's just sometimes it's a lot easier to use elimination than it is to use substitution. So I can either try to make my x's match up so they have opposite coefficients, or my y's. I'm going to choose to try to match up my y's because I've got a positive 6y and a positive 3y, which means I know I can multiply this second equation to make them match up, so I have positive 6y and negative 6y in the second equation. In order to get this second equation to turn into negative 6y, I'm simply going to multiply each side by negative 2. So now I'm going to rewrite my first equation, 5x plus 6y equals negative 8. And then I'm going to rewrite my second equation, but multiplying everything by negative 2. Negative 2 times 2x is negative 4x. Negative 2 times positive 3y is negative 6y equals negative 5 times negative 2 is 10. And notice, now I've got what I wanted in the previous lesson, a positive and a negative with this variable with the same coefficient. So now I can just add these two equations together. 5x plus negative 4x is 1x. My y's cancel out. Equals negative 8 plus 10 is 2. So I get 1x equals 2, which just means x equals 2. That was pretty easy. Now that I know x is 2, I can take it and plug it back into any of my equations. I'm just going to plug it back into this first equation. 5 times 2 plus 6y equals negative 8. 5 times 2 is 10, so I get 10 plus 6y equals negative 8. Subtract 10 from each side. 6y equals negative 18. Divide each side by 6. Y equals negative 3. So I get x equals 2, y equals negative 3, and then don't forget to always write your answer as an ordered pair. So as you can see, there was really only one new step. It was multiplying this second equation so that I would get it matched up where I had a positive 6y and a negative 6y. So when I added them together, my y's would cancel out.